In this video, we'll discuss vulnerability scanning. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College. The creation of this video was funded by a National Science Foundation Advanced Technological Education grant. My name is Philip Kreger. I'm an Associate Professor of Cybersecurity at Embry-Riddle Aeronautical University in Daytona Beach, Florida. We'll start the video by defining what a vulnerability is. Next, we'll discuss vulnerability scanning, its purposes and uses. Next, we'll run a vulnerability scan on a network. And finally, we'll interpret the results of the vulnerability scan. Now, as with all of these videos, this is a very high-level overview of vulnerability scanning to introduce the concept to the interested person. More detailed videos can be found on YouTube and in other sources. So let's try to define what a vulnerability is. So a vulnerability is a weakness in a computer or network that can leave it open to an attack. And there are hundreds or thousands or even hundreds of thousands of reasons a computer or a network may be vulnerable. So some of the reasons include improper configuration of the computer, the operating system, or applications, or even improper installation, or poorly coded software applications. And recall we talked in a previous video about this concept called a white hat hacker. And a white hat hacker is essentially an external cybersecurity consultant, not always, but usually, who has been authorized to perform some sort of penetration testing or vulnerability scanning on a company's network. Now, a vulnerability scan is one of the tools that is used as the first steps for penetration testing. But also, these tools can be used by malign actors, that is, hackers. So what information does a vulnerability scan produce? So if you've watched the previous video on network scanning, where we used Nmap to scan a network, it provides a lot of the same information, but even more information and more detailed information. So like the Nmap scan, it produces the IP addresses of the devices that are connected to your network. It identifies the services you're running on each device. And additionally, it shows potential vulnerabilities identified on each device. Now, that's above and beyond what our port scanning did. But it also shows links, usually to sources regarding more information, including mitigation strategies. That is, lessening the potential for the attack. And it's usually by upgrading the software. Now, before we go further, this is also something that was mentioned in the Nmap video, and that is port scanning legal? Because essentially a vulnerability scan is a port scan with more stuff added. So as we've already discussed, port scanning is essential to network security, and IT companies scan systems every day as they help to confirm network configurations and compliance with security policies. But hackers, those malign actors, also scan systems. The hackers use scanners to gather information on potential targets and their vulnerabilities, and as a result, port scans can be seen as precursors to attacks. Millions, if not billions, of unauthorized scans occur every day, and in one study spanning 12 years, a single site received 23.4 billion scans. So with their role in cyber attacks and their ubiquitous use by IT firms and security consultants, a question is raised of, are port scans legal? As of 2020, in the U.S., there's no federal law that exists that bans port scanning. But at the state and local level, there are no clear guidelines that exist. And remember that laws can change from day to day and year to year. However, while not explicitly illegal, port and vulnerability scanning without permission can get you into trouble in a couple of salient ways. The first is a civil lawsuit. The second is complaints to your ISP. So the amount of risk associated with a port scan is largely based on whether it's authorized. If you did not receive permission, then you're at greater risk of backlash, either through a civil lawsuit, which is something you certainly don't want, or even complaints to your ISP. So if you did receive permission, always ask for permission, then get it in writing and have it signed. Now, if you're doing this on your own home network, I'm assuming you've gotten permission to do that from yourself if you own your own house, or from your parents or whoever is authorized to provide you permission. So always make sure that you're either doing this on your own home network that you own, or you've gotten that written permission. So let's look at a couple of different types of scans. The first is something called an authenticated scan. An authenticated scan allows for the scanner, that is, you and your software, to directly access the network-based assets and all the devices connected to an organization's network. So that includes computers, wireless devices, routers, switches, and things of that nature. Authenticated scans are typically run internally by a cybersecurity provider, which could be the white hat hackers, or a trusted user, or your IT team. However, authenticated scans can also be run by intruders who have gained the credentials of a trusted user. And the second type of scan is something called an unauthenticated scan. And these are performed externally without direct access to the network and can only examine publicly visible information and is unable to provide details about the operating system and the installed software. However, unauthenticated scans add valuable insights from a hacker's perspective. Remember, we talked about those white hat hackers. So both types of scans are useful to an organization as they determine an organization's internal and external security posture. So one of the first things you need to know, if you don't have a fully qualified domain name like Microsoft.com or Apple.com, more than likely you're going to be using the IP addresses of the devices that are connected to the network. And the way to get those, or to identify those, is usually through running, if you're on Windows, the command ifconfig *more. And the bar and the more just means that when you run this command, the results are going to scroll off the end of the screen, and so this gives you a page-by-page view. So this ifconfig command is going to be run from the command line. And so I've run this here on my Windows box, and you see some of the information associated with the network. You see the words Ethernet adapter, Ethernet, and if you look down at the IPv, that is the IP version 4 address, you see the IP address of this computer. You also see the subnet masks, and that tells me that there are 255 potential IP addresses on this network. And below that, you see the IP address of the default gateway, which is .0.1. If you're on a Mac or you're running Linux, you're going to run the command ifconfig *less from the terminal. And as you see down under the device name EN0, which may be different on your Linux device, but you'll see that there's an INET address. Notice most of those INET addresses say 6, and those are for IPv6, Internet Protocol version 6. But we're looking for the INET address, which is the 192.168.0.4. If you look all the way across to the broadcast address, this also tells me that there are 255 potential IP addresses for the devices connected to this network. Once we have our IP addresses, we can start up our vulnerability scanner. And for this demonstration, I'm going to be running something called Nessus. And Nessus is a commercial-grade vulnerability scanner. It's a very powerful scanner with the capability of scanning hundreds of thousands of devices. However, because it's powerful and it does have that capability, it's very expensive. But they do provide the capability for scanning a home network that has 16 or less devices. And this version of Nessus is called Nessus Essentials. And so this is the Nessus interface, and it runs in a web browser. And it runs in any web browser. But once you install Nessus, this is what you'll see, regardless of your operating system. So in the left-hand corner, you'll see that it's got My Scans and All Scans. And so we can click here. And if we look under My Scans, we'll see that I've already run a scan on one of my networks. And some of the other things are kind of extraneous for a high-level demonstration, so we won't talk about that until we run one of the scans. So what we want to do is we want to start a new scan. So we're going to click up in here and start a new scan, and this shows you all the different potential scans that you can run. And I'm not going to get too in-depth into this, but you can see that a lot of these that say upgrade on it are for the commercial version, which is going to cost you hundreds or thousands or even more dollars, but that's well worth it for a large corporation. But what we're going to do is we're just going to run something called a basic network scan right here. Actually, if you look up above here, host discovery, what If we watch the Nmap video, that's essentially what Nmap does, the host discovery. And all that does is it identifies the IP addresses of the devices on your network. But we want to run something a little more advanced, which will actually not only find the IP addresses of the devices on your network, but also the port numbers that are being exposed by those devices, as well as any vulnerabilities. So we're just going to select Basic Network Scan, and then we're going to give it a name, My Second Scan. You know, you would always give it a better name than that, but this is just a demonstration. You could give it a description right here, the folder in which to save it, and then the target. So we saw before the Class C IP network range that we're going to be using is going to look something like this, and this is going to be using CyTE notation. We could also do 192.168.0.255 as well. We could do either of those. So let's leave it at that. And then we can click Save down here. And notice now that it says My Second Scan. It says Schedule on Demand. Last modified, it says not applicable. But notice here is that you have these little right arrowheads over here that indicates that you can launch this. So let's go ahead and we'll launch that. And notice now the My Second Scan is moved up. My Basic Network Scan, the first scan I ran, has already been run successfully. And now you notice this little green rotating arrow indicates that the scan is running. And my previous scan took about 10 minutes. So what we can do is we can pause this one and go to my previous scan. Notice that we can pause this one. There we go, that's paused. And let's go to the scan and look at the results. If we look over here on the right, it shows the scan details. The policy that was run was a basic network scan. The status is completed. It was using a local scanner. It started at 10:32 a.m. and ran for about 11 minutes. Below that, that gives you a diagram of all the different potential vulnerabilities. And notice that the vulnerabilities run from critical to info. And so the ones we should really be concerned about is probably not the info and the low, but look at the medium, high, and most certainly the critical. If we look here in the center, this shows you our hosts. We have 1, 2, 3, 4, 5, 6 hosts that are connected to the network. So that was our network discovery. And the IP addresses associated with that. And then in the middle are the actual breakdown of the vulnerabilities which have been color-coded. Notice that most of these are just informational. So it's not that they have a critical vulnerability. So we can click on one of these hosts, and let's look at the worst one right here. And we see that there are quite a few different vulnerabilities. A lot of these are just informational, which just means it's information. So if you see that there are some of these that are indicated they are mixed. And so this indicates that Mozilla Thunderbird has multiple issues. Microsoft Office does, VMware Fusion, Google Chrome, Wireshark, Mozilla Firefox, and SSL. Let's go ahead and we'll click on this top one, Mozilla Thunderbird. And this tells us that there are 3 known critical vulnerabilities with respect to Mozilla Thunderbird, which is just a free and open source mail program. If we look over here to the right under vulnerabilities, this is telling us with regard to Mozilla Thunderbird, the various percentages of critical, medium, high, and informational vulnerabilities. Let's click on this top one, and notice this gives us a lot of good information. So it gives us a description of the vulnerability, which is the version of Mozilla Thunderbird installed on the remote Windows host is prior to 52.5. It is therefore affected by multiple vulnerabilities. The solution or the mitigation strategy for that is just to upgrade to Mozilla Thunderbird version 52.5 or later. Notice also if we wanted to, we could go down and we could visit this website, which gives us more information about the security advisory that was published by Mozilla.org. If we look over here to the right, we'll see the severity is critical. Every vulnerability will have an associated ID. Regarding risk information, there's this CVSS, which stands for Common Vulnerability Scoring System, and it tells you a little bit about how this vulnerability was scored. And I believe these run from 0 to 10. So anything that's like, the base score is 9.8 would indicate that this is why it is a critical vulnerability. Down below this, you see that it's got more information on the vulnerability, but what I want to show you is this reference information. So notice this says CVE right here, Common Vulnerability and Exposure, and all of these are links. So we're going to click on one of those, and we're going to open the link in a new tab, and that provides us more information about this vulnerability. So notice the actual vulnerability name is CVE-2017-7826 detail, and it tells us more information. That is the current description of the issue. Below that, it shows you the severity. And notice that the base score, as we saw in Nessus, was 9.8 critical. And we can scroll down and find more references regarding advisories, solutions, and tools. And this is kind of outside. This is way more detailed information than we need for this video. It's interesting to go in and look at these references to see exactly what they're talking about. But the big things that we see here are 2 or 3 things. The first thing of which is the fact that we know that this version of Mozilla Thunderbird is vulnerable, and that the solution, that is the mitigation strategy to mitigate this issue, is to just upgrade the version of Mozilla. Now we can go back to the vulnerability group, and let's go, and we'll just keep on going back, and we'll see if there's anything else. Notice that our .0.3 only has basic information. Here's our .01. This is my home router. Let's take a look at this. SSL issues. Well, that's not good. The SSL certificate cannot be trusted. We'll take a look at that. Okay, so the secure socket layer certificate cannot be trusted. The solution is to purchase or generate a proper SSL certificate for this device. And we can keep going back and see if there was anything else of interest. It looks like, for the most part, it's just our 0.4, which is my Windows box. Right now I'm running this on an iMac, and it is 0.6. Okay, and for the most part, my iMac is very secure. That's because it's brand new. And I keep it up to date with any kind of patches that come out. Okay, so what did we learn from this? Well, it tells us a lot of things. This vulnerability scan told us that we have 6 devices connected. So, if you think about it, you probably think you know the devices that are connected to your network. But what about Wi-Fi devices? I actually have a separate Wi-Fi network, and there's 17 devices on it. And I can never remember what I have connected to it. And so one of the great ways of trying to remember what you have connected to it and whether those devices need to be patched with software upgrades is running a vulnerability scanner. And there's one more site I want to show you, which is MITRE's CVE site. And CVE stands for Common Vulnerabilities and Exposures. And this is one of the sites that aggregates information about vulnerabilities. And so this is a nice site to go to because you can go to the list of entries right in here. And then you can search by CVE ID, which usually you probably don't know, but you could search for a keyword. So for example, in here, if I want to search for Windows, let's say 2012, that will show me all of the different vulnerabilities associated with Windows 2012. And then we can click on one of these and we'll find out a lot of the same information we find in Nessus. It just shows you a description of what the vulnerability is, and usually there's something about mitigation strategies associated with this, or there's an external reference that you can click on. For example, here is the portal for Microsoft.com to find out how you can mitigate this vulnerability. And for the most part, the best mitigation strategy is usually just to upgrade the software. That is to patch the software. And on Windows and the Mac, that's done automatically. Windows is done every second Tuesday, I believe. And on the Mac, whenever there's an upgrade, Mac automatically connects to the security servers that are run by Apple and will download those security upgrades and install them. So you can do that all automatically, and it's probably the best thing to do unless you're running a critical server, and then that's outside the scope of this discussion. So in conclusion, what did we learn? That vulnerability scanning is a useful tool that identifies potential vulnerabilities on devices that are connected to your network. that Nessus is a powerful commercial tool that can be downloaded, installed, and run against your home network. Now, the Nessus version I used here was Nessus Essentials, and that will run against a maximum of 16 devices that are connected to your network, and it can't be used commercially. This is only for home use, and it's also good for students to learn. There's also another tool that I didn't talk about because it requires a bit more tweaking, and that is called OpenVAS, and that's an open source tool with many of the same capabilities as Nessus, and it runs on Linux. And again, I want to make sure you understand the importance that if you want to scan any network that's not your own, that's not under your control, that you need to have received authorization, and that authorization should be a written document that has been signed by the authorized person. And as you recall in our Nmap video, is that we ended up scanning a device, a computer that's on Nmap's network, and it's called scanme.nmap.org. And so you can also scan that as well using Nessus, or you can go ahead and you can scan your own home network. This video has been brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College.